Hi there, welcome to lesson 2, day 2. Today we'll be talking about graphical displays that are meant for categorical data. And categorical has the word category in it. Categorical data is non-numeric. Or if they are numbers, they're just descriptive numbers, non-number data. Alright, so I hope by now you've noticed several things wrong with this picture, folks. It doesn't seem to be a very fair graph at all, I'd say. I want to show you some of the things that I've heard that are wrong with it over the years. All of these things have been brought up to me at one point or another. It doesn't have a title, so I've always called it the coolness meter. You know, the bars are not the same width, and that's not fair. The spacing between the bars is not the same, and that's not good either. The scale on the y-axis does not go up in equal steps. Folks, if this is 3, then that ought to be 6. The labels on the x-axis are certainly not uniform. Font is super tiny here. It grows a little bit each time, but finally seniors is huge. Seems like we're trying to draw some attention to the seniors part of this graph. There's a color only on one bar. Folks, that really isn't fair either. That means all these others pale in comparison, if you will. The label on the y-axis, there isn't one. So we don't even know what this is measuring at all. So lots of things wrong with this graph, but it helps us to remember what needs to be part of every graph. And I would ask you to think about that for a moment. Good graphs should have descriptive titles and labels, bars and spaces equally spaced out. Units should go up equally. Colors should be uniform or complementary. When I say that, this is my preference. Okay, the thing is to show your data in a non-prejudicial way. So we would use all the same color, that's uniform, or complementary. That is, if we're using pastels, they'll all be pastels. Don't throw in one bright fluorescent orange. Colors shouldn't do anything to detract from the message of the graph. And the y-axis has to go up in equal steps. Same thing with the x-axis as well. So today we're going to be talking about bar graphs and some of their, I call them close relatives, because they're all related to bar graphs in one form or another. So I thought we'd start with this totally made up data of the number of each of these pets owned by students in a stats class. According to this chart, there are 15 dogs that are owned among the students, 17 cats are owned, etc. To make a bar graph of this, I don't know about you, but I do know me, and I need to have a y-axis and an x-axis if I'm drawing freehand for sure. These are number of pets, maybe is a good title for this. Along the x-axis, we're going to have 1, 2, 3, 4, 5, 6 bars. So I'm going to try and set out markings that are equally spaced so that, if you ignore that curvy line. Ideally, I'd like my spaces and my bars to be the same width. So let me see what I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I might have to bleed over here just a little bit. Okay. My first bar, so these are the pets, or the type. And this is the number of that kind of pet that's owned. The highest we have to go on the y-axis is 17. So maybe if we go by 5s, 5, 10, 15, and 20. Dogs, we have 15 of them. Now, I could, and I think I will, start right here because that means I'll get my most accurate right there. These are dogs. We have 17 cats, but folks, this is not a number line, so there should be spaces in a bar graph. 17 cats, so whoa, that was crooked. 17, these are cats. Hamsters, we have 10 of them. And you know about bar graphs, you've done this a lot. So I'm going to go ahead and finish mine, and then I'll catch up with you in a second. So there's my graph, my bar graph. Each bar should be the same width. If you're going to color or crosshatch, you should do that to all the bars, not just a few. Spaces should be uniform as well. They don't have to be as wide as the bars, but they need to all be the same space. Just nothing that's going to detract from the message of your graph. Okay, bar graph. A Pareto chart is a close relative to the bar chart. In fact, what it is, it's a bar chart with its bars in decreasing order. You use that to show which categories are the most influential. So if you think about that with the data that we had, the only difference would be cats would be showing up first, dogs second, and the other category would end up here. Yeah, we've got some rearranging. Let's just do that real quickly. It won't have to be perfect, thank goodness. Frequencies don't change, 15 and 20. I'll go ahead and draw mine, and then I'll catch you back up here in just a minute. This is a number, and these are the types. Again, that doesn't change. Here's my completed Pareto chart, and this is also about the number of pets that people own. But all the Pareto chart does is say, let's put the bars in decreasing order. Again, that shows which are the most influential categories, and you can quickly see how they measure up to each other. Another form of bar graph you'll be familiar with. You saw these a lot when you were younger. The pictograph uses replicated pictures to represent frequencies, like one stick man represents 10 people, something like that. For our pet display, if we were going to do that in a pictograph, the one thing that we should remember is all of the pictures have to be the same, and they have to be the same size. So you wouldn't want to pick a dog, okay? You'd have to pick some symbol that was representative of a number of animals. So I don't know what that might be, maybe a dog house or something like that. But it has to be the same picture each time, and the picture should always be the same size. It shouldn't get bigger to represent more, because bigger implies area, and we know that area grows faster than quantity. So it should be the same picture, always the same size. You just use more of them to represent more things. The USA Today newspaper uses a lot of pictographs, or they used to. I don't look at that very often anymore. Next, we're going to talk a little bit about another graph that we're familiar with, and that is the circle graph. I've got the same pet data from before, and we're going to make ourselves a little pie chart. That's what many people call these. You'll see that I have my circle drawn with a dot in the middle, and I start out, folks, by making a straight line out to the side. That is going to be the lower side of one of my bars. I've already done a little bit of math here, but I want to explain what I did. There were a total of 57 pets represented here, so I took the frequency and divided by 57. Then to find out what portion of the circle that percentage represents, so what percent, that percent, times 360, since there are 360 degrees in every circle. So we're going to take that frequency divided by 57 times 360 to get ourselves the sizes of our pieces of pie. I've already done that math. Let me just put my results up there. 15 over 57 was about 0.263. I rounded to the thousandths place, and when I multiplied, that's about 95 degrees. 17.298. Again, let me fill this chart out, and then I'll catch up with you here in just a moment. Okay, there we are. There's the completed table for this one. Again, to get the percentages, I took the frequency for each category divided by the total number of pets, and that total was 57. Then I multiplied by 360 to get the number of degrees. Now, you can see my note at the bottom. You can certainly do this with technology. I am going to attempt to do it with my math tools here in Active Inspire. We do have a protractor, which is what you'd need for this. Our crosshairs right on the center of the circle. And I need to show a 95-degree angle. If this is my 0 line, and I'm reading the inside scale, and 95 is right about there. I'm going to make a little mark up there. I'm going to move my protractor in that direction, right up like that. The next piece of pie for me has to be 107 degrees. My baseline is now changed, and I want to make sure I'm on the crosshair, and I need 107 degrees from this baseline. So on the inside again, 107, right about in there. I am not going to be as accurate probably as I'd like to be. However, you can see what we're doing. We're going to go around the circle. Now the baseline is changing to the last line that I drew, and from there I need 63 degrees. Inside scale again, 63, right about there. From there, so let me just get that lined up. Okay, 13 degrees. So we're talking right there. And from that mark, 32 degrees. 32 degrees from there. From that mark, it should be about 51. I'm going to just check it to see how close I got. There's the marking. And I'm a little off, but that does not surprise me since I was not using a straight edge to draw the lines. Okay, let me finish putting my lines in there. We were here, we were here, we were here. And the way that we are going to label this is totally up to you. What I would not want to see, however, the one thing I would not do is put the number of degrees in here. People don't care about that. They may want to know about the percentage. And this is my dog category, and that was around 26%. This was my cat category, around 30%. My hamsters, around 18%. And I can see I'm going to have a problem fitting in some of my descriptors. Bird is not going to fit there. So it is okay to do this. That's my bird category, and that was 4%, roughly. Rounding is going to cause this to not come out real nice. Fish, and I had 8 or 9% there, rounding up almost every time. And then the other category, about 14%. All right, that I know is a review of things that you've done before, but it never hurts to see it again. In fact, you're going to look at some problems, or a problem, where I ask you to draw a circle graph in class tomorrow. So I hope that you will rewind this and listen to it again if that's necessary. I think what's important is remembering where these numbers came from. We took the frequency for each pet, we divided by the total number of pets to find a percentage, then we multiplied that by 360 to find the number of degrees that belong in our graph. The last type of graph that I'd like to talk about just a little bit today is called a line graph. And line graphs show trends over time, folks. So the x-axis is always a timeline, perhaps years or days or minutes, whatever the case may be, months of the year. A line graph then shows frequency, which makes it part of the bar graph family, okay? But it just shows things in a different way, because as time marches on in whatever your situation is, frequencies change. So perhaps we start here with our first reading, here with our second, then down a little and up, maybe like a stock market ticker. You could think about that. We all hope that keeps going up, but that's not always the case. A line graph, the points show frequencies at a given time, then you draw the lines. They're not indicative of how quickly a substance is growing. However, you can tell when a slope is the steeper, that would be the more quick growth. But what we're saying, if this was January and this was February, for example, it doesn't mean that it grew at a steady rate from January to February. It just means that at the end of whenever we read it in January, it was down, but when we read it in February, it was up. Again, this is not showing the change day by day by day. It's showing an average change over a period of time. All of these graphs can be done in Excel or other computer software, and that's not a bad idea. They certainly come out more accurate than mine did. What I would ask you to do is get out there and try that You Try exercise this evening. We'll be graphing in class tomorrow. Bye-bye.